Hello, and a very warm welcome back to my YouTube channel. Trust you're all well, in good spirits, and ready for some more examiner report wonder to help you in your quest to make that wonderful IA you are destined to make. So this is on 2019. It's the second in the series that I've done for examiners reports. Don't forget, smash that subscribe button at the bottom. Let's hit that magic 1,000 for the end of 2020. At least put a star of joy, of positivity on the top of this year of you-know-what. Right, preamble. Again, very popular are kinetics experiments, so rates, concentration, temperature. There's bazillions of rate reactions, iodine clock, of course, BZ reactions, disappearing cross, the list goes on. There's dozens and dozens of them. Very popular, and if done well, awesome, very good. Calorimetry, again, very good, if done well. T and anthocyanins, that spectrophotometry, can be done very well. And galvanic cells, concentration, temperature, nature of the electrode, change the salt bridge, all that. VITC, oh, the lovely VITC, and the amount of calcium ion EDTA titrations, again, very popular at the end of last year as I'm speaking now. They all scored very well if they had continuous, quantified data. If it was, again, just to emphasize the point, brand comparisons, we should not see any of those now. We should just not see them. If you're still doing it, in the bin, put it in the bin now, bye-bye, bye-bye. Okay, databases at the end of last year, interestingly, not very many. Why? Because COVID had not happened, okay. The Winkler method has been on the syllabus since 2016. Its popularity seems to increase with each iteration or each year of the IA submissions, and why not? It's great. It's a 4-to-1 reacting ratio. It's got some nice it's got 4 equations that you can work through and explain, do your uncertainties well, and have a nice question, effects of temperature on oxygen concentration, link it to a real life situation, my local park pool, my local swimming pool, and again, it's not suitable to just do purely qualitative internal assessment, so there must be numbers, all right? This is chemistry. We don't want to see bar charts. Personal engagement, everyone gets 1. It's hard not to get 1, okay? Because personal engagement is about you actually doing the experiment, okay? You did the experiment, you did some research, you referenced it well, yeah, that's a 1. So how do you get the second point? How do you get the magic 2? Because each point, for me, is sacred, and none should be thrown away in any way, shape, or form. Again, it's 20% of your internal assessment, your IB grade, your IA. Massive amount. Nothing else will have a bigger impact on your overall grade than the internal assessment, so do not throw any marks away. Undemanding research questions. What's the enthalpy of neutralization of hydrochloric acid and sodium hydroxide? Well, I'll tell you now, it's minus 57 kilojoules per mole. And if you don't get that answer, you're wrong. There's something wrong with your experiment. And it's also, everyone knows this. Everyone knows it. So don't be doing things that everyone knows, because that's not going to get you 2 on personal engagement. It should have a real-life application or a real-life situation. I've already mentioned looking at your local ocean water. You could look at your local soil. You could look at your local foodstuffs in the supermarket and look at the effects of X on Y. Okay, as long as it's continuous and it's quantified, you've got your uncertainties, you propagate your uncertainties well, you do a graph, you discuss your systematic and your random errors, everybody's happy. There was a comment on the last video that the IB expect too much and this is not even on the syllabus. Well, no, I'm sorry, you are wrong. Because if you look at topics 11.1 and 11.2, systematic and the random errors and quantification of them is clearly part of the syllabus. So review your notes. The other big problem was failure to resolve clear limitations in the original method. Specificity is something which IAs are marked down for on an alarmingly frequent basis. There seems to be a massive assumption that if you throw some water into a vitamin C containing fruit, everything that comes out is vitamin C. Well, it's not. There's all sorts of water-soluble things in an apple, an orange, a kumquat, a durian, whatever it is that you're happening to be reacting with. So you need to make sure that your assumption that you are actually measuring is specific. Your method is specific to the target molecule you want to get, because rarely will that be the case. So how do you do it? Well, you look at what else could actually be contained within the matrix that you are extracting, and you comment on that as part of your error analysis to show you are aware and you are personally engaged, which is this criteria. So there's no reason why you can't get those top 2 marks. Exploration, problems. Let's start with the problems. We're here to learn stuff. Okay. A poor research question, I've mentioned one already, without continuous data will score poorly in exploration, in analysis, and in evaluation. Probably, if you've not been engaged enough, it's not going to do well in personal engagement. So everything stems from a really good research question. Effect of X on Y. Quantified, repeats, trials, reacting to the experiment that you're doing. If it goes wrong, it's chemistry, it will go wrong. Explain how the design of the methodology was decided. 90% of IAs that we see, the methodology is based on, or perhaps may I say copied or borrowed from, a standard site that we're all aware of. Okay, but we need to see a paragraph for the top marks for exploration before your method, explaining why that method was chosen, how that method was chosen, and why that range of independent variables was chosen to assess the research question. Then you can go to the top bands on exploration. Control variables are often poor. It's not enough in a IB diploma internal assessment to put a list saying temperature, pressure, concentration, humidity, air pressure, operator, type of equipment. You need to have a table tabulated. I've mentioned Andrew Weng before. Look up Andrew Weng, or look on any of my other videos, how to get a 24, how to mark a database IA. They both have IAs in there showing tabulation of the control variable, what it is, what the impact is on the experiment, and how you can actually control that control variable. You need to have a level of sophistication, way more than just a basic list of saying these are the control variables. Okay. The control variables mentioned in the design, but they're not done in the method. So they've said they're going to look at effective concentration and they're going to keep temperature the same. But in the method, there's no mention of keeping the temperature or monitoring the temperature. Sometimes experiments go over days and students assume it's at 25 degrees C. Don't know why, because it's not. We know it's not. Okay. So poor control of your control variables in your method is a massive reason why you're not going into the 5s and 6s and you're staying in the 3s and the 4s. So all your identified control variables must be in your method with how you're actually going to control them. These are the control variables. So temperature over many days, as I've said. Another thing mentioned with students, we're not including the waters of crystallization in mole calculations. Why not? I don't understand. Why not? Limiting reactants is classic. Look at the effect of concentration on rate, yet they don't consider which concentration is limiting, which is in excess, to prove that they're actually testing the research question. Now that's fundamental chemistry, okay? And we shouldn't be seeing that sent to a moderator. That should be picked up by the student, and certainly by the teacher. Enthalpy of combustion of alcohols, we always assume, or the students always assume, they're 100% pure. This is totally ethanol, propanol, butanol, whatever it happens to be. It's not. Pure reagents cost an absolute fortune. There are many impurities, normally water, to be honest, in alcohols, and that should be in the discussion. Beer-Lambert law, this is often applied to suspensions, and suspensions do not follow the Beer-Lambert law, A equals ECL. Plus, the Beer-Lambert law does not hold at low concentrations or at high concentrations, and there was definitely an absence of awareness of the limitations of the Beer-Lambert law in the submissions for November 2019. Electrochemistry, the controls should be, if you're looking at the effect of concentration on the EMF, you should be looking at separation of the electrodes, how you chose the salt bridge, what's it made of, it's potassium nitrate, what is it? You might mention temperature and pressure as control variables, but if it's not in the exploration method, then you're not going to get the top marks. Okay, so it all needs to link together, all needs to mesh at the various phases as you elucidate and curate your internal assessments. And clearly, if you're using a pH meter, if you're using a balance, if you're using any piece of kit, which is going to change over time, and they all do, then you need to include when it was last calibrated. That is just good laboratory practice for a practicing chemist. look on the back of your balance. When was it last calibrated? And it was mentioned that some schools were using universal indicator paper and litmus. And I pulled myself back up off the floor and said, oh my gosh, why are they doing that? That's not appropriate for a diploma IA. Analysis. Photos are okay. We don't have one photo with some nice labels going onto it. Again, look at my How to Get 24 video up there, and it shows a lovely IA with a labeled diagram, a labeled photograph. That's wonderful. But just a photograph on its own, occupying half a page or even sometimes a full page, it doesn't help. It doesn't add value. We just recognize that as a piece of filler used in your IA to get to the 12-page maximum. Okay. Another thing is, in the method, students have been putting the qualitative data they would expect. So magnesium and acid, it's going to bubble. We know it's going to bubble. But you can't sit from your armchair or from your school desk and say, I expect bubbles to happen. What's the point of that? Raw data, any data. They mentioned that in the methods, schools are getting very good at including the numbers. Every number has an uncertainty in the method. So measure temperature at 20.0 degrees C plus or minus 0.5 degrees C seems to be getting home to schools. But the raw data often has missing uncertainties, and whenever there's a number, I've mentioned this just about in every video I've done, whenever there's a number, put the uncertainty with the units. The value and the uncertainty should both have the same units. Okay. Not recording initial and final volumes for titration, still done, just giving the total volume. Please send the initial and the final and the total uncertainty. You add the 0.05 in the first, the 0.05 in the second, to get 0.1 centimeters cubed. A problem with the analysis is if it's just simple averaging, particularly when they don't include any anomalies or outliers or how they've arrived at the average. If it's just a simple, I don't know, 3 repeats at one concentration for an absorbance and it's 0.12, 0.13, 0.14, clearly it's 0.13, but that's not so easily going to score in the higher bands because there's just no sophistication to the calculation there. I know some people won't like that, but you've got to recognize we need to reward schools who actually go that extra mile and do the chemistry and do the hard yards on the mathematical treatment of the data. It's not a matter of doing a GCSE or MYP. I'm going to average 3 things and I'm going to get full marks. It doesn't happen. Okay. Bar graphs and scatter plots. Everyone knows this now, right? Not appropriate. Don't do it. Iodine clock, the reciprocal of time, 1 over t is not the average rate. I'll say that again, 1 over t is not the average rate, it's the instant rate. If you want the average rate, you have to do it change concentration and divide it by the time. Standard deviation, very popular. Stop it, don't do it. If you have less than 5 values that you're putting into that standard deviation calculation, because it's not valid, you will not get any marks for uncertainty. Less than 5, don't do it. And if the uncertainty on your data is plus or minus 0.2, and all your data is 0.1 something, 0.2 something, clearly there's no trend there because your data is within the uncertainty range. And that's often not recognized by schools, by students, or indeed teachers, that the data is basically meaningless if it doesn't go beyond the uncertainty range. Evaluation, again, the hardest one to do. Students often overstate the trend because, as I've just mentioned, it's within the uncertainty range. There was a positive, negative correlation, whatever it happens to be. But if it's not beyond the uncertainty range, no points, not good. We want to see chemistry, we want to see science, and reputable academic websites should be well known to you by the time you do your internal assessment for your formal IB diploma score. Things like Science Daily, IFL Science, all these things. There's billions of them. We want to see Nature, we want to see New Scientist, we want to see academic journals, we want to see university references, okay, or at least the recognised websites, ChemGuide or PubChem or ACS, all these things. Identification of weaknesses and limitations is mainly procedural, and procedural will only get you 2s and 3s out of 6 on evaluation. For the 4s, 5s and 6s, it must be methodological, and by that, how are you going to reduce the identified systematic errors in your internal assessments? They make specific reference again to elucidation, treatment of systematic, the magnitude of systematic and random errors. Again, someone complained they're not on the syllabus. They are. Looking at 11.1, you'll find systematic and random error analysis, and all IB students for chemistry should be familiar with that. A superficial improvement is do more. Use a better instrument. Change the operator. I was an idiot. Never put I was an idiot. Okay. A better thing to do is to say calibrate it at frequent intervals. Calibrate it just before you do the experiment. Why was the range chosen? Remember when I said earlier, when we're looking at the method, that you need to describe why you chose that method to test your research question and why you chose that range. Okay. So maybe when you come to your evaluation to get those 5s and 6s, you need to adapt the method in response to what you found to address the systematic errors present within your internal assessment. Extensions should be clear. It's not enough to say, I'm going to use a better pH meter. Okay. You need to state how that would influence your conclusion to your research question. Okay. Communication. This is really good if there's lots of detail in your methodology and your methodology tests your research question and nothing else. All the data you gather should purely be to test your research question. It's like throwing a ball at a basket. There's no point throwing the ball at the wall if you want it to go in the basket. The research question is your basket. Get the ball in the basket. Okay. Each calculation, one example of each. Thank you very much. No examples, you're going. We don't care about cover sheets, indices, contents pages. Who cares? We don't. Stop doing it. Any background not relevant to the research question. I was looking at development IA for one of my students this morning, and she was talking about, for a full page, the reaction quotient Q when she was looking at KC. And she made no connection between why it should be there. I assume it's because it's at non-equilibrium conditions. She never said that, and she's only looking at equilibrium conditions. So I marked it down because it was irrelevant information to what she was actually testing. It may be relevant if she explained it better, and it's only a draft so she can change it and make it better. But that's the sort of thing, and moderators are looking for that. We are chemists. We are aware of what is relevant to what you're studying. And we are aware when you're just waffling away and hoping that some of it sticks. Pictures of chemicals and common apparatus. It's not suggested, don't do it. We don't need to see another picture of a titration. We do like pictures in the qualitative data bit with the arrows coming in. That's all good. But just more pictures of chemicals and apparatus. We don't need to see that. Please use SI units and IUPAC nomenclature, which you should be familiar with from your developmental experiments or developmental IAs you've done before the final one. And just to say again, the references must be scientific, not general science news. So the key guidance was from the November 2019 report. We're a November school. I think if you watch this in tandem with the May 20 examiners reports, that'll be fantastic guidance to lead you into your May 21 internal assessment. The research question must be chemistry, clearly chemistry, where the answer is not known beforehand. I said that at the beginning, we'll say it again. Explain how the method was developed, how you arrived at the range for your method, how you chose the IV and the CV to test your research question. Again, not since I was a little person. I've been very interested in the Nernst equation, for instance. There you have it. Record any adaptations as you move through the internal assessment. This is best practice. This was my method. I realised it sucked. Don't put that. It didn't work. The method didn't work. So I changed the method to respond to that new piece of information. And now I'm getting these results. Brilliant. Best practice. Safety is very good. Environmental and ethical are doing less well. We should be using judicious quantities of reagents, of chemicals. We should be using the minimum concentration that we need to use to test that lovely research question which you have developed. We should be dispersing through authorized channels if absolutely necessary, or finding a substitute which is less toxic to again test the research question. So please include a section on ethical and environmental and how you have addressed those concerns. That links into the green chemistry, which is precisely that replacement, reduction, and 100% atom economy will be a nice thing to put. And don't forget, revise 11.1, 11.2 before you even start your IA. That's what you're being assessed upon. Your grasp of number and how you can elucidate a wonderful report from your fantastic research question. Okay, that's all from me for today. Thank you very much for watching. Smash that subscribe button